Okay, so today I'll be doing a rotational motion written problem from set 1. This is actually the first problem in the set. So, it says, a solid uniform disk of mass m and radius r is pivoted about a horizontal axis through its center, and a small object of mass m is attached to the rim of the disk. If the disk is released from rest with the small object at the end of a horizontal radius, find the angular velocity when the small object is at the bottom. Okay, so how do we work through this? Well, first it helps to just write down the energy equations. So what we know is that the initial potential energy plus the initial kinetic energy plus the initial rotational kinetic energy is equal to the final potential energy plus the final kinetic energy plus the final rotational kinetic energy. And now we can, in this equation, by the way, it's important to note that we don't include friction in the term. We don't include work done by friction because we're assuming the system is frictionless. And starting here, we can start getting rid of terms. So we know that the initial kinetic energy and the initial rotational kinetic energy are both zero at the start because the system isn't moving. And we know that the final potential energy is zero because basically because we said so. I mean, the object, the potential energy is relative to that point. So now we can start writing down the actual equations. So potential energy is equal to mgh, and that's equal to the final kinetic energy plus the final rotational kinetic energy. So the kinetic energy is of the block of mass m, and we know that kinetic energy is equal to 1/2 mv squared. And the rotational kinetic energy, this is of the disk, is equal to 1/2 I omega squared. Okay, so now the next part is to see what else we can substitute into this. So what you could do starting here is substitute I into the equation. So I for a disk, and you actually have to look this value up, is 1/2 mr squared. So now that gives us mgh equals 1/2 mv squared plus 1/2, and now we have 1/2 mr squared. Keep in mind that this little m and this little m are both the same. I mean, that's how this problem is set up. They're just both of mass m. So that comes in. That's important in a future step. So keep that in mind. 1/2 mr squared times omega squared. We really just substituted I into this part, and now we can start canceling out the m because we can divide both sides by m. So m cancels out, and that leaves us with gh equals 1/2 v squared plus 1/4, just multiplying a half by a half, r squared omega squared. Okay. Now, another thing is we have to get everything in terms of omega, since that's what we're solving for. We're solving for angular velocity, which is omega. So that brings us to the relationship between the two, which is and you'll find this on your equation sheet. Omega equals V over R. Now, since we have to turn V into omega in terms of omega, that makes omega R is equal to V. So, now what we can do is start substituting that into the equation. So now we have GH is equal to 1/2, and now this is V squared, so if V is equal to omega R, then V squared is just equal to omega R squared, which is omega squared R squared. That's the algebraic principle there. Plus 1/4 R squared omega squared. So now it's interesting, these two terms look really alike. You have omega squared R squared here and omega squared R squared here. And since you're solving for omega, that comes in really handy. So try to see where you can get from here. You could pause the video now and see if you can work through the rest of this. Okay, so at this point we have GH equals 1/2 omega squared R squared plus 1/4 omega squared R squared. What you really have to do here, and this part is kind of visual, you have to realize that H is equal to R, because the change in height of the block from the initial point to the final point is just R. It goes from here to here. So that gives us GR equals 1/2 omega squared R squared plus 1/4 omega squared R squared. And now you can divide both sides by R, which helps you simplify some stuff. So G equals 1/2 omega squared R squared plus 1/4 omega squared, or 1/2 omega squared R plus 1/4 omega squared R. It's not R squared now because you've divided it by R, so now it just becomes R. That, when you combine, or when you factor it out, it becomes omega squared R times 1/2 plus 1/4, which is just 3/4 omega squared R. Now, from here, the rest of it is also just algebra. You get 4G equals 3 omega squared R, which means 4/3 G is equal to omega squared R. And now, to finish with the algebra, you get 4G over 3R equals omega squared. What you're doing here is you're moving G to the numerator, and then since you're dividing by R, it becomes 3R in the denominator. And you take the square root of both sides to find omega equals the square root of 4G over 3R. And that's the solution. So really hope that helped, and thank you for watching.